The problem that gave me the most trouble on test number 3 was the last problem, which was about motional EMF. So in this problem, we have two conducting rods and they each have a length L and a resistance R, and they're being pulled with constant speeds, V and 2V. So the one on the right is being pulled at V and the one on the left is being pulled at 2V. So these rods, they're sliding without friction, and they're two stationary horizontal conducting rails on the top and the bottom. And we also have a uniform magnetic field which points into the page. So part A asks us to indicate the direction of the conventional current flow. So for this problem, we first have to see which way the two rods polarize. And in order to do that, we have to use the right-hand rule. So to find magnetic force is equal to QV cross B. So using our right hand, which I'm going to show you right now, using our right hand, we're going to do the magnetic force due to the left rail right now, or due to the right rail. So for the right one, we're going to do QV, and right now we're going to do the electrons. So our thumb is going to point in the direction of QV. So V is going to the right, but since these are going to be electrons, it's going to be pointing to the left. And then our hands, they're going to fold into towards the direction of the magnetic field, which is into the page. So if I do QV cross B, the way that my fingers curl would be the direction of the magnetic force. So my fingers are going to curl down, which causes the electrons to collect at the bottom of the rail, the rods on the right. So for the rod on the left, we're going to do QV cross B as well. So V is going to be to the left, but then QV is going to be to the right. And then we have to curl our fingers in the direction of the magnetic field. So this one is kind of difficult. So our thumb is going to be QV and then cross B. So our fingers curl, our fingers are going to go towards the direction of the magnetic field, and then the way that they curl will be the direction of the magnetic force on the electrons. So that is up. So the electrons are going to collect on the top right there, which means that the protons are going to collect on the bottom. So that is the way the two rods polarize in this problem. And so that allows us to conclude that the conventional current flow, so we pretend that these two rods are batteries, and current flows from out of the positive end into the negative end. So it's going to go from the positive into the negative, and then out of the positive into the negative. So the way that the conventional current flow flows is this way. And then for part B, it just asks us to indicate the way the two rods polarize, which we already did to find part A. So that is all.